Welcome to a video lecture series on course Control System Engineering. So this is the first lecture series, the Introduction to Control System. So in this series, we'll discuss about what is meant by a control system and example for the control system and types of control system like open loop control system and closed loop control system. We'll get into one topic. So we'll look into an definition for the control system. The control system is a system which consists of n number of components are being connected together to perform some specific function. So where your output is controlled by your input. So based on your input, what you are giving, your output gets controlled by an input. So where your controlling process being done there. So it is in control system. So the simple definition is like the number of components being connected together to perform some specific function in which your output is controlled by your given input. So here we look into an slide. You can see that simple block diagram of the control system. The one simple block which represent a control system where you have input of the system is input what we are giving to this system, and you have the output. So here your output is controlled by an input. So based on, so the whole control system is represented by single block, and here the output is controlled by an input. So this is a simple definition and simple block diagram of a control system. So we can take an example for the control system like day-to-day life, what we are using like washing machine and toaster. Traffic light control system is one more good example for an control system. So here all the systems been designed for a specific application in which where your output is controlled by an input parameters, right? So this is an definition for a control system. So in control system, we have a classification like open loop control system, and two types of classification is there. One is an open loop control system and closed loop control system. Open loop control system and closed loop control system. So first we'll look into an open loop control system. So here the open loop control system. So you can see the simple block diagram of an open loop control system. So the plant here represent your system. The plant, it is represent your system. So for the system, the input is input what you will get it from a controller. So you have an input to a controller, and from controller you will get an actuating signal that's been given to your system, and you will get an output. So this is a normal the control system, the open loop control system. So where you will give an actuating signal to the plant or system, and you will get an output. So your input is given to the controller, and that controller produces an actuating signal, and that signal being given to an plant or system, and you will get an output. So here your system produces output which is controlled by your input. So this is an this is the open loop control system. So you can take an example for an open loop control system is like a traffic light control system is a very good example for a traffic light control system. So and other examples like washing machine, tank level controller, timer based washing machine. So in timer based washing machines, what will be having, the machine is like you'll be setting in time for this time duration like 20 minutes or 30 minutes to be on for rinse purpose, or 10 minutes for the rinse purpose. There's the time being fixed there. So it not look into an output what it is obtained. So it will not look for an what actual output they got. So the continuously the system operates, and you get an output. So this is one of an example, and one more example for the toaster is like one more example for open loop is toaster. So here toaster like will be given timing like 2 to 3 minutes to toast the toast time being given to one system, and the 3 minutes that the system will be on. So it will not see whether it is toasted or not. Any feedback it will not get it. So based on the time duration what we have set it, that time the toaster will be on, and you will get an output. So this is a one more example for the example for an open loop control system. So here the simple one more example for an open loop control system is a traffic light signal. So here input is applied on it is applied in a predefined sequence. So the control activities of this traffic light signal is like for some specified duration of the time, the either one of the light will be an on. The signal timing here is determined based on an traffic analysis at the junction. So it is then the timings been identified by predefined study on traffic analysis at that junction. So you don't have any feedback. So based on the study, the time duration for the three lights been set. The controller does not monitor any traffic density at that time. So it will not at that time it will not check for any traffic density at the time. So based on the timings what is being set. For example, so you have the traffic light like red, green, and yellow. So you have set like red is for 60 seconds, red is for 30 seconds, and green for 45 seconds, and yellow for 5 seconds. So this time period being set by using an predefined determined time analysis on the junction. There is predefined studies. So based on the previous studies, this previous studies on the junction, this time seconds being setted. So it doesn't take any feedback from what is the actual density of that point at that junction at that time. So it is not considered all those things. So it is like a previous study analysis. So this time being set. So that time that particular light will be based on the time sequence. That particular light will be on, and after that the green light that will be for 45 seconds, and the next yellow light. So that sequence being continuously done. So this is one example. So the time based control here is done. So it is the whole system operates on time based. So it is example for an open loop control system. So the whole system here like all red, green, yellow lights being it is operated in a predefined sequence manner at predefined time. So it doesn't get any feedback from an output, like it doesn't monitor any actual traffic density from an actual traffic density or a vehicle flow at that real time. So it is an example for an open loop control system, right? So then the advantage of the open loop control system is like it is very simple and economical, and we can easy to construct. So easily we construct this one, and the output also stable. In disadvantage, like here the accuracy you will not get in an open loop control system, since you don't consider the disturbance at an output. So that disturbance is not automatically corrected here. So the disadvantage here, it is inaccurate, and the disturbances at an external environment is not automatically corrected here. So these are the advantage and disadvantage of an open loop control system. So we'll get into our next closed loop control system. So look into the diagram. From diagram itself you can understand. So here you take the feedback elements. Here you take the feedback elements like feedback elements. So from output you take the feedback elements, and that being given to your error detector, where your controller will get an error signal as well as your input. So that input you will get it from your. So not only input, you will get an error signal from the feedback signal. So your error detector will give an error signal. So that will be given to your controller. Then the controller, based on that error signal, the controller will give an actuating signal. Give an actuating signal to the plant. Again, the plant here represent a system, and based on that you will get an output. So the feedback signal, the feedback from an output is taken, and that is given to an error detector. Your error detector will give like a error signal to the controller. The controller will give an actuating signal to the system or the plant. So in closed loop control system, so the output is fed back to your input. So the output here is fed back to your input. So your control action is dependent on your desired output. So it is desired output is your actual output. So it is controlling action is depends upon your desired output. So that's what here you have the error detector that produce the error signal, which is difference between your input and your feedback signal. So from error detector, you will get a signal which is the difference of your input and an error signal. So this feedback signal is obtained. Feedback signal is obtained from an feedback elements. So the error detector, which gives an input minus your feedback signal. So that is an error signal that is given to the controller. That controller will produce an actuating signal. So this plant which is nothing but a system, so the system gives an output. So here the controlling action is performed and it depends on some feedback elements from an output, right? So here you can take an I think so you understand, like so here you in closed loop control system you have feedback elements. From feedback elements you will take an feedback from the output, and that being given to your input along with your input, and along with your input as an error signal you will give it to a controller. That controller produces an actuating signal. That actuating signal you will give it to the system, and you will get a desired output. So the here example again, here you can take an example like a traffic light control system which having a sensor at an input. So the previous in control system in a previous example for open loop control system where we discussed about on traffic light, there we don't have any sensor, right? So you don't have any sensor there. So where what you the signal timings being set by using an some traffic study on that particular junction, right? But here you use the sensor, so real time you will take you will get an input from the sensor. So based on that sensor your the particular light seconds gets varied. So red, green and orange light seconds gets varied. So from based on an output on particular time, the sensor so like sensor the real time data has been obtained by the sensor, like traffic density. So it is if the density is too large, so number of vehicles are there, or else the number of vehicles are too low. So based on that, based on the sensor output, your red and green orange lighting seconds be gets varied. So this is one of the good example for a closed loop control system where you have the feedback from your output. So real time you are getting an data from the sensor, and that been given to an input, and from the controlling action is been performed, and that is given to the system, and you will get a desired output, right? So this is one of the example for a closed loop control system. So the main thing in open loop control system you don't have any feedback. In closed loop control system you have a feedback from an output. So we'll look into one advantage of an closed loop control system. So closed loop control system is very accurate when compared to one open loop control system, since here external disturbance here been corrected by an error detector and error corrector. So here um, the system here is very accurate, and since it is more stable when compared, so the open loop control system also stable, but when compared to an open loop control system, closed loop control system is more stable, and it is less affected by the noise. Since you have an you will take an feedback, so external disturbance also you are considered, so noise been get into that one, so that is being considered to correct your output. So these are the advantage of your closed loop control system. So disadvantage is like the system is so complex when compared to an open loop. So since you need an error detector where to detect an error, so it has to process a feedback signal and an input signal, so that the system construction gets complex and expensive. And feedback in many closed loop system, the feedback is may lead to some oscillatory response. You don't get an exact response, so some oscillatory response you get. So when you are designing a closed loop control system, you should be more careful. So how it is processing, right? So you can take a simple quiz like so identify. So that's all about an open loop and a closed loop control system, and advantage and disadvantage of a system. And also I gave an introduction about an what is meant by a control system. So I think you understood about what is control system and types of control system, open loop and closed loop, and what are the advantage and disadvantage of it. So you have some quiz here, just try to answer it by yourself. So identify whether the following systems are open loop or closed loop. So the man driving an automobile. So if the man is driving an automobile, so whether it is open loop or closed loop, so you have the output is controlled by your input here, and it has a feedback, right? You have the man has a sensory unit like eyes. So based on that sensory unit, so it gets in like in sensor output it get, and that is actuated here, right? So this is a closed loop control system. And the person searching for the book on the table, again it is the person has an eye that act as a sensor, so it gets in real time data, and based on that the searching being done. So it is also in closed loop control system. The blind man searching for the book on the table, so it comes under an open. So if you are considering an vision alone is a factor here, then that is an open loop system, because the blind man visionary system, it is zero, like he doesn't know whether where the book is there, so it will not get an feedback. So in that case, uh, sorry, in that case, this one is an open loop control system, so you don't have any feedback from the person, that eyes of one person. So if you are taking, if the same person is taking as a touch as in sensor, touching is an as like in sensing unit, that time it is a closed loop control system. And again, the walking in a prescribed direction, so inserting thread into a needle, so it is all a closed loop control system. So these are the some example for an open loop and closed loop control system. Yeah, thank you.